In this video, I'll go over the ratio structure for the F statistic. Yes, the F statistic is actually a ratio. Let's take a look. And probably the best way to look at this is by looking at this graph. So we have total variability, all the ways that the scores vary. And we break that down into two different types of variance. There's between treatment variance and there's within treatment variance that we've already talked about. And as a reminder, when you have variance between the 3 different groups or the 4 different groups or however many groups, that variance is due to 2 different things. It can be due to the independent variable, whatever treatment I've given. That can make differences between the different groups. And then there's also that random unsystematic stuff that we talked about, the individual differences, the error, the random by chance type of error. Within treatments, as we mentioned before, only measures, within treatments variance only measures random unsystematic variance. It's that weird variance that just happens when you have different people in a study. Because everybody in each individual group is getting the same treatment, that the only thing that you can attribute any differences to would be this random unsystematic stuff. So we have total variability, again, broken down into between treatments variance and within treatments variance. So these two sources of variance form the structure for the F score. And if we take a look at it, we have the mean squares between, the variance between, divided by the variance within. Now we've already said that the variance between the different groups is a function of the treatment effect plus that random error, and the variance within the groups is simply random error. And so the numerator and the denominator are both measuring random error, but the numerator also measures error that can be attributed to, or differences I should say, that can be attributed to the treatment. So here's another way to say it. When the null hypothesis is true and there's no differences between the groups, the F ratio we say is balanced. That means that when there is no treatment effect here, the random error is going to be equal. And when you have equal numbers in the numerator and the denominator, you get the number 1. Anything divided by itself is 1. So if we don't have a treatment effect, all we have is this random error that's happening, our F score is going to be 1. But if we do have a treatment effect, that's going to make the numerator larger. And our denominator will be smaller than the numerator, which will mean that our F will be more than 1. Here's another way to say it. When the numerator and the denominator are measuring the same thing, simply random error, the F ratio will be near 1. When the sample data produce an F statistic near 1, there's no significant treatment effect because the numerator and the denominator are just the random error. It doesn't include the variance that can be attributed to the treatment effect. All right, in the next video, we're going to talk about the notation for ANOVA. See you there.